All right, Algebra 1B students, welcome to part 2 of lesson 9-7, where we decide what type of function is a good model for a specific set of data. Today, we're going to use tables of values to decide if a function is linear, quadratic, or exponential. In our last video, we used graphs to do that. In this video, we are going to use tables of values. Okay. Now, the easiest one to tell is linear. And in order to decide, we will again look at the differences in the y values. Okay, we're going to look at the differences in the y values. How much are those changing? In this first example, as you can see, if I add 1 to the x, I add 3 to the y. Negative 1 up to 2 is add 3, 2 up to 5 is add 3, 5 up to 8 is add 3. And I'm adding 1 over there the whole time. Okay? If the difference between the y values is always the same, meaning adding something, or subtracting, right? Or subtracting, obviously, then the function is linear. As long as I'm adding or subtracting the same number every time to go from y value to y value, if see, my x's are going up by 1, or the same number every time. So that's linear. Hopefully that's one that we can see pretty easily, because we're adding the same number to our y's every time we add an x. If instead of adding a number or subtracting a number, if we are instead multiplying or dividing, to go from y value to y value. For example, here when I go up one x value, I times my y value by 2, and here I do it again, and here I do it again. Okay, so I'm timesing by 2 every time I change an x value. I multiply my y value by 2. If the difference between the y values is always multiplying or dividing by the same number, the function is exponential. Okay, so if I'm adding or subtracting, my function is linear. If I am multiplying or dividing, my function is exponential. Okay? And the last one is quadratic, and this one is a little bit harder to see. We will work through it together. If necessary, we're going to check what's called the second differences. The second differences, which means the difference between the differences. And so look at this example with me. As we can see, as we add an x number, x, we do not add the same number to our y's every time. The first time I subtract 2, and then I add 2, and then I add 6, and then I add 10. Okay, so that number that I'm adding or subtracting is changing every time. So it's obviously not linear. And I'm not multiplying by anything either, because 1 times 7 is 7, 7 times 7 is not 17, so multiplying doesn't work. So now I look at the second difference, meaning the difference between the differences. So now I'm going to look here at my first differences and decide how is that changing. Well, to go from negative 2 to positive 2, I added 4. To go from positive 2 to positive 6, I added 4. To go from positive 6 to positive 10, I added 4. So every time, I'm adding 4 to the difference in my table. Okay? If the first differences are different, that would be these guys. But the second differences are the same, that would be those guys. The function is a quadratic. Function is a quadratic. Okay? Linear, you're adding or subtracting the same every time. Exponential, you are multiplying or dividing the same every time. Quadratic, you're not adding or subtracting the same thing every time to your y's, but you are to the differences in your y's. Okay? Now, the way this is going to look in your practice problem set is like this. You'll be given a table of values and asked to decide which type of function best models the data. Well, let's look together at letter A. In my x values, I add 1, add 1, add 1, add 1. That's nice. So I will look at the differences in my y values. Let's see. To go from 9 to 5, I could multiply by some crazy fraction, or I could take away 4. To go from 5 down to 1, I could divide by 5 or take away 4. To go from 1 to negative 3, I could take away 4. To go from negative 3 to negative 7, I could take away 4. Because I'm taking away 4 every time in my y values, letter A is a linear function. Now let's look together at letter B. Again, in my x's, I'm adding 1, 1, 1, 1. That's good. In my y's, to go from 0 to negative 0.25, I took away 0.25. No way to multiply that one. To go from negative 0.25 to negative 1, I took away 0.75. To go from negative 1 to negative 2.25, I took away 1.25. And to go from negative 2.25 to negative 4, if I were to subtract those two numbers, I'd be taking away 1.75. If we think of this in terms of money and quarters, I think we can see that every time I go down, obviously my difference is changing. But my second difference, these differences, I believe are all 50 cents. 50 cents. 50 cents. So because it's 25, 75, 125, 175, I'm adding 50 cents or 0.5 every time I go down one of my differences. That means first differences are the same, first differences are different, second differences are the same. This is the quadratic. I would like you to take a look at these ordered pairs, please. This function here. I would like you to decide which type of function would model this set of ordered pairs, this data in this table here. Okay, pause the video, take a look at that, please. Come back and I'll tell you what we should get. This function is exponential because to change my y values, I multiply by 2, multiply by 2, multiply by 2, multiply by 2. Okay. Times 2, times 2, times 2, times 2. If you have questions about using a table to decide which function is best, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a great night.